Okay, so how's everybody doing? We're great! Good. Right. I won't use the word fun, but is everyone ready to have like a reasonably good time at VanJS? I want to keep it a little reserved initially. Alright, let's get started. This talk is on Facebook's React for building user interfaces. I am not from Facebook. I'm from a totally different place. Is there anyone here from Facebook Vancouver? Hands up if you are. Okay, that's awesome, because that means I get to make up all kinds of stuff and fact check. Yeah, I'm not from Facebook, I'm from this place. This is where I hack on JavaScript and Ruby and HTML and CSS. And maybe you've never heard of us, but if you're one of our over 700 authors who write ebooks with our workflow and publish online and release their in-progress ebooks, get reader feedback, pivot until they have the right book, and then get traction once they do, then you guys love us, and you love the 90% royalty that we give to you. We let you sell online. I don't just do this stuff. I also build bikes. That's me with my belt drive, single-speed hipster. And that's, I like to grow stuff. I like to bake stuff. I like to make iOS apps and sometimes rock on and or out with various bands and stuff. So that's me. And this is my very first conference talk ever. I take a little bit of solace in the fact that it's my first one, because that means that statistically this will be my worst conference talk I've ever given in my entire life. Statistically, that's a fact, right?
But statistically, it'll be the best one you accept.
That's right, it'll also be the only one and the best one, but also, no matter what happens, I can always use that as a scapegoat and say, well, statistically, it was going to be the worst talk I've ever given, so just lived up to its name. But I know I don't have to worry because, I'm among my peeps. You guys are my peeps. This is the only room where I can say things like the following and have it be totally cool. Things like, who here has ever, by raise of hands, inserted anything into their own DOM or the DOM of somebody they know? And see, that was totally above board. So, for those of you who raised your hand, you know that DOM insertion can be very painful. Very slow process. Constructing DOM is slow. Inserting it, rearranging it is slow. So, when you're building user interfaces, you want to minimize DOM insertion as much as possible to have the most reactive experience. And, here's, just in very broad terms, here's a bunch of DOM fragments. Don't worry about what they are. Divs, ULs, doesn't matter. So if we were to go from the before state to the after state, how many things, just shout it out on the count of 3, how many pieces of DOM have we inserted? 1, 2, 3? 2. All right, so most of us agree that 2 things have been inserted into this DOM. And in this case, it's a little bit different. So we started with New York, and we ended with Los Angeles and Kansas City, right? So how many things do you think were inserted into this DOM? How many things?
I can't really see the screen super well. I think 2 things were inserted into this DOM.
Yeah, you'd reasonably say 2 things were inserted in this DOM and maybe 1 thing was removed. Well, Facebook React would like to disagree. It would like to differ on this point. Facebook says, you know what? We already had some perfectly good DOM here that we didn't really need to destroy. And this is the state we want to end up in. We want to end up with 2 pieces of DOM with those characteristics. So Facebook React considers this to be 1 DOM insertion and 1 modification of the textual content of the existing piece of DOM. So whatever container had New York before, they just changed, they did the minimum amount of change possible to make it appear on the UI as though it says Los Angeles, and then they added only one piece of DOM, cutting down on the DOM manipulations. And Facebook basically maintains 2 copies of a sort of a shadow DOM. It's an in-memory JavaScript DOM from the before state. And then they ask you to construct that same exact JavaScript representation of the DOM in the after state. And then they diff the 2. And they say, if we were to start with that, assuming that that's already rendered in the document, in the tree, and we wanted to end up at that, what are the minimum number of mutations we would have to do to get from here to there? So that's the basic idea. That's the whole idea behind React. And so, this part of the talk, I hesitate to say it's a little bit of reading the manual to you, but I'm going to try and value add it because I know you didn't come to have a manual read to you. But this is how we build UI with React. So we say, let's do this, and React says, all right, I'm gonna need some stuff from you. And the way we create a UI component, the way we encapsulate it, you call React create class and you pass it a bunch of options. So let's take a look at some of those options now. So the very first thing you need, at minimum, is you need a JavaScript function that, given a certain state of the world, renders a piece of DOM. But it's not using HTML. We don't use HTML templates here per se. What you do instead is you create this object, React DOM, and then use a tag name, and then you pass it 2 parameters. The first parameter is a bunch of attributes on that DOM element, just like you would normally have an ID or a class or those kinds of things. And then the second parameter is what you want to have that DOM node contain. So here's an example. We might be creating a button and then using passing it a bunch of attributes like an on-click and a passive function. And then we want the contents of that button to just be the string quit. When's the last time you saw things like this? On-click handlers and things. Those of us who have worked with HTML, that's a little bit repugnant to us. But, well, it's headed back there with React. We're bringing it back. But the good news is this does not attach literally attach an on-click handler to the DOM node. Behind the scenes, React is going to sniff this hash of options you pass it, and it's going to do the right thing as much as possible. So whereas I just say old school, oh, stick an on-click handler on that button, it'll be fine. Here's a function to fire when you click it. React is going to behind the scenes do event delegation and all the proper things. You can also, other than creating DOM inline, you can pass it a whole other React component. So you can nest React component and compose them to create mega React components. So sweet. And so here's an example. If we were to take our city list, let's imagine we had in the state of our object somewhere, we had a list of cities. So the first thing we might do is we might create for every city in the object state, we create a React DOM LI, and its only contents are the name of the city. So in the first case, that would have just been New York, and the second case, that would have been 2 LIs, one with Los Angeles, one with Kansas City. And then we would say, take those items, those children that we've constructed, and return them in a UL with the class name cities on it. And that's that. All right, so that's the DOM rendering function. Notable here is that we're not returning HTML templates, we're returning this other in-memory JavaScript representation of a DOM. We can also configure it with some lifecycle callbacks. Anyone who's ever done any Objective-C or any view controller programming, this will be this will feel like home. You have callbacks before a component mounts, you can run some code, and it gives you the DOM node that it's about to mount. Right after it does mount, and just before it unmounts. My computer just unmounted. unmounted from display. You can also, React components have this notion of properties. Properties are kind of like their public API, where you instantiate a component with certain properties, and when those properties are about to change for whatever reason, you get this callback saying, well, what are the properties about to change to, so that you can do some stuff. And then you also have challenges. You also have a component did update, so whether the properties, the external things, or the state, the internal state of it changed, you get whatever the previous property in the previous state were, and you get the DOM node, and then you can manipulate it further. Whenever the properties are about to, also this is a method that you can implement to say, if you think you're smarter than React and you think that you know whether a component should be updating or not based on what kind of things have changed in the state or the props, you can just implement this method that returns true or false, and you can say, you know what, based on what I know the properties are now and what the properties are transitioning to, you know what, don't bother re-rendering this element, because I know for a fact that it's not going to change. And then you can do some other stuff. You can say, when I instantiate this, this UI element, if I didn't give it some properties, here are some defaults. So let's say we're making a game and we say, you know what, the default turn limit is 30. And then when it gets constructed, the initial state will just set, turns remaining to the turn limit. And then we'll start decrementing turns remaining as we go on. You can also enforce requirements and also some types on properties. You can say that the name's got to be a string, turn limit's got to be a number, and also the name is required. And you can also do mix-ins. All of the lifecycle callbacks that I've just shown you, you can take another object of those lifecycle methods, and you can stuff them in as mix-ins, and it will chain them together. They don't override each other, they just chain together. All right. So once you've defined a React component, then you just use render component, you instantiate it, you don't need to use the new keyword, my React component, create it, you can store a local instance of it, and then you can stuff it in some existing DOM node, usually just the body of the document. All right, so here's an example of a complete React component, putting all these things together. Ugh. Sorry, that's kind of a mouthful. It's a lot of code to throw on a slide. I wish there was something I could do about it. Oh, I know. CoffeeScript. That's what I'll do about it. That's much cleaner. So let me point some things out. I'm going to create a city list. I'm going to create a React class, and I'm going to pass it an object with exactly 3 keys: prop types, get initial state, and render. Down here, once it's all done, I'm going to create it, and I'm going to pass it an object with exactly 1 key, country, set to the string Canada. So prop types, I'm going to say this prop types is an object where the key country is just this guy telling React that it's a required string. Get initial state, I'm going to pass it a function, that little arrow, start of a function, and this function returns an object with the city's key, and I don't know, just imagine that we're pulling a list of city names out of somewhere keyed off the country name. This little amphora in CoffeeScript is the this keyword, so this.props.country. And then the render function. This is particularly nice in CoffeeScript because it nests sort of like you would expect DOM to nest. So we're saying, for every city name in state cities, this is a list comprehension, we're saying create a React DOM LI using the city name. So this line turns into an array of LIs. And then we pass those as the children to React DOM UL, giving it the city name, or the class name cities, and then the children, whatever this evaluates to, which is an array of LIs. And now you know some CoffeeScript. I won't bother you with that anymore. And now, once you have your React component and it's rendered and it's in the DOM, you can do stuff like you can say, hey, component, set state, and then you can pass it a new version of the state. You can pass it a totally new version of the world. It will re-render all of that stuff in memory, not touching the DOM. It'll compare it to its last known rendering, and then it'll do the minimum number of manipulations possible to get yourself into that state. So then you can do things like this, and you can say, hey, set state, and pass it a totally different list of cities, and again, we'll only do the minimum number of manipulations to get that done. All right, so I said about testing this. Does it really work? So to see if it really worked, I needed a contrived demo. So here's what we're going to do. We're going to take some source data. I need a big fire hose of data. So I'm going to ask the web audio API to just make me a big fire hose of data. Make me a sine wave, something like that. And then I'm going to ask the web audio analyzer, just give me a bunch of amplitude data, and I'm going to carve it up into a grid. And then for each grid square, I'm going to calculate a brightness. We'll build an audio visualizer. I'm going to calculate a brightness, what that grid square should be. And then we'll just stuff her into a big, we'll create a bunch of view models, an array of view models. One for every grid square. And then once we have them, we'll just render them back in as divs. So each square will become a div with a background color that has that brightness. Is that clear what we're going to do? So we're going to take a fire hose of data, and we're going to do two things. We're going to have a native JavaScript implementation that just creates DOM and stuffs it into the document. And then we're going to have a React version that does basically the same thing, but React behind the scenes is going to be handling a bunch of reconciliation for us to try and improve the performance. So, what's our render time budget? Well, let's say that we wanted to squeeze this thing out at 60 frames per second. We would need to take only 16 milliseconds per frame to make that happen, roughly. That includes skimming the data off the web audio API, deciding what to do, creating the DOM elements, stuffing them in, letting the browser reflow them, and then waiting for a paint cycle to paint that to the screen. We've only got 16 milliseconds to get that done, assuming we want these crazy high frame rates. So, are you guys ready to give it a shot?
Oh yeah.
Yeah? All right. I'm going to pull up the frame per second meter in Chrome, the Chrome DevTools, and we're going to give this a shot. Let's see how this works. So, I have no idea what's going to happen here. This is a live demo. It's going to change based on what happened at home. But we're going to show you a native version doing a 32 by 32 grid, and then we're going to see React do the exact same thing. All right, ready to go? Let's do this. So, we've got a native version. Whoa, it's just slamming those DOM elements into the DOM. Amazingly, at 40-ish frames per second. So that's pretty good. That's pretty good. So again, this is skimming off the audio API, getting that fire hose of data, creating sort of an internal representation of it in terms of view models, which are just objects with brightness properties. And then saying, I'm going to create a div for every one of those view models and just stuff it into the DOM. And it's managing to do this at roughly 40 FPS. All right, let's take a look at the React version. Whoa, we've achieved almost slamming up against that 60 frame per second ceiling. So that's pretty good. Let's take a look at sort of what's going on here. So if no one's played with the timeline in Chrome, it's really awesome. You can take a sample and see what's happening. So these timelines represent sort of the drawing of a single frame. And it's a little bit small for the people in the back, but I'll point out what's going on. In this little section here, that's the web audio API taking the data and preparing the view models. So that happens in almost sub 1 millisecond, so we can pretty much throw that out. And then from here until here, this is the implementation sort of deciding what DOM to render. And then from here to here, this is the browser having received that DOM and trying to reflow it and draw it back out on the screen. And then these green bits at the end. These green bits are basically a constant between both implementations because the browser is going to, the green ones represent painting. The browser is going to paint at a constant rate no matter what the JavaScript implementation is. The paint is basically contingent on how complicated the CSS is and how complicated the rendering is. So prepare the data, prepare the DOM, reflow the document, and then paint it to the screen. And these time scales are roughly the same, so we can compare these apples to apples. So that's the native version. The React version takes this much time to decide what to do, but it makes better decisions once it has. This is React constructing the in-memory DOM version of what this visualizer is going to look like on the next frame. And then it compares its old rendering of it and goes, you know what? I really only need to make a couple of DOM manipulations to make this happen. So this makes many, much better decisions than just doing a naive re-render the whole screen kind of thing. All right, so let's crank it up a notch. Let's go, instead of a 32 by 32 grid, let's go 64 by 64. Yeah? What's up? All right, here we go. Here's the native version. So it's kind of chomping on it at 10 FPS. Here's the React version. How are we doing? It does better with the browser window focused. That's Mavericks trying to give it a nap. So we're, with the exception of some dips, kind of hitting around a ceiling of 30 FPS. And there's something else I want you to notice. Because React is only manipulating the DOM that it needs to touch, there are a whole bunch of black divs here that don't need to be touched between frame to frame. And just to prove, or just to demonstrate what's going on here, I have a button that will mark all of the divs in the document red, just so you can see React's only touching the ones that it needs to touch for any given frame. And another side benefit of this is that I can do things like I can put hover classes on these divs, and because the divs are not being torn down and recreated, that cursor is still hovering over the same element. So I can do things like that. I can have a hover class over, if I go back to the native version and I try and hover over something, it's going to destroy the div that I was hovering over every frame. And if I try and mark, it's just blowing away the whole DOM. And if you're sitting there thinking to yourself, well, that's not a fair test, the test was designed to do the most naive implementation in both, using both approaches. So it's a naive, slam all the things into the DOM at once, and it's a naive, change the entire React state at once. But React just makes better decisions about what to update. So taking a look at the timeline for this one, we see the same sub-millisecond preparation of the data, so that happens very quickly. And then here, rendering a bunch of DOM, and then the browser reflows, relayouts, and then repaints. React, making its decision in its internal representation of what to update, updating very little, but we're starting to get slammed by GC a bit, because I imagine inside React there are probably more allocations happening for this process. So we're starting to see more garbage collection, and I haven't proven it, but my theory is that that's what's causing the sort of sudden dips in performance, back up to, and then a dip. But we'll see, it could be other things. All right, now we'll push it to the wall. So 32 by 32, we went 64 to 64, and now we're going to go 128 grid by 128 grid and see how it performs. So here's the native version. at 128 by 128. And it broke the FPS meter. So the FPS meter doesn't even want to participate anymore. But if you feel like counting 5 seconds and counting how many frames, we can probably come up with a number. And here's the React version. Now the React version takes a bit to boot up. And then once it gets going, chugs along at roughly 6, 7, somewhere hovering around 6 frames per second. Much better than the native version. And we still get all the benefits of DOM reconciliation and the like. And so, native version, even though the time scale is getting stretched out, it looks much the same. I'm going to create a bunch of DOM, reflow it, and then repaint it. React here, between here and here, is making the decision of what to update, getting slammed by the garbage collector, and then making very efficient updates and painting to the screen. So I'm not sure what the next step for React is, but I have a feeling with some tweaks to the internals, it could, even a naive implementation like this could screen quite fast. All right, so only have one more thing to say. If we were to apply a little bit of smarts and try and optimize either one of these implementations, this is one way you can do it. So you remember the should component update configuration param that you can pass to React. And we can say, between state changes, that's supposed to say next state, state. Between state changes, should we even bother trying to reconcile the before and after? So we're saying, you know what, if the brightness before doesn't equal the brightness after, then we want to return, yeah, true, the brightness has changed, so yeah, we should be updating this component. But if they're identical, then it returns false and says, no, don't even bother giving it a shot. And thanks to Pete Hunt from Instagram for that suggestion. So I want to show you 2 last things. We're going to have a little bit of fun. I know I said we weren't going to. But we'll have a little bit of fun with a native implementation and an optimized version of the same thing in React. So here we go. A little bit of fun. By sound of applause, who here is sitting in a chair today? Pretty good. It's 64 by 64 grid using the Web Audio API, instead of a sine wave, the microphone as an input. And then the final thing that I have for you today, thank you very much for being a very good audience, and I hope you have a great rest of the time at Van Dev Week, whatever you're gonna see. But here we have an optimized for React version. And again, by sound of applause, who thinks that they can clear all of the red squares from this screen?